Benching Hotspot. Hope you are doing well. On student demand, we have brought a topic named Combined First Law and Second Law of Thermodynamics. So, let us begin. First, let me write the first law. First law of thermodynamics. First law says that dou Q minus dou W is equals to du. Remember, this is applicable for all process, for every process, for all process, applicable for all process, whether reversible or irreversible, whether reversible or irreversible, whether reversible or irreversible, applicable for all substances. All substance, whether solid, liquid, gas, anything. Solid, liquid, gas. The gas may be ideal or real. This is the basic law, okay. But if we write for closed system, this is for closed system, okay. This is for closed system actually. This expression is for closed system. Now, if we take the process to be reversible, if you take the process to be reversible, then del W you can write as PdV. You can write it as PdV, okay? And we know that del Q by T, or from second law, you know that ds is greater than equals to del Q by T. For a process, this is applicable for a process. If ds is equals to dq by T, then this is applicable for a reversible process. Reversible process. While if you write ds is greater than dq by T, this will be for irreversible process. If you try to change this thing into equality, then you have to write ds is equals to entropy generation plus del Q by T. This is for irreversible process. So, if I am writing for a reversible case, then delta W is equals to PdV and delta Q for a reversible case it will be dq is equals to TdS. You can write. So try to replace this thing here. So it will be TdS minus PdV is equals to du. Now, if you try to observe this equation carefully, look in the expressions, each expression carefully in this equation, you will see this ds is a property. ds means change in entropy is a property since it's a point function. dv is also a property. It depends only on the initial state and final state. And du is also a property. It also depends on the initial and final state. So all the things in this equation are property. It is independent of path. It does not depend on the path. So it is applicable for all the process. This equation is applicable for all process. All process, whether reversible, irreversible, everything. Then this equation is also applicable for all the substance. Applicable for all substance. You can use this expression for all the substance, whether solid, liquid or gas. Okay. So this is the general equation what you have got by combining the first law and the second law. Now if you try to write the similar equation for a flow process. For a flow process, you know, for flow process, and basically steady flow process. So you know delta Q minus del W is equals to dH plus dKE plus dPE. If you neglect changes in kinetic energy and potential energy, you will be left with only these terms. Now try to replace for a reversible process. For a reversible process, you can write, for reversible case, if you want to write for reversible case, you can write del Q is equals to TdS, and you can write del W is equals to minus times VdP. This is applicable only for reversible case. Now substitute here. So it will be TdS minus plus, so it will be VdP plus VdP is equals to delta H. Now try to look this expression again carefully. You will see here ds, that is point function, dp, that is also a point function. Means delta p will be only depending on the initial and final state, and again delta h is also point function. So this will be a general state equation, and it is applicable for, again it is applicable for all the process, applicable for all process, for all the process, applicable for all substances. Okay, so these two equations are very important, and these are applicable for any kind of things, because all the terms involved, they are properties, and it is independent of path. I would like you to give some more information regarding Gibbs free energy. Gibbs free energy. Okay. So what is Gibbs free energy? This is basically given by G is equals to H minus Ts. If you are taking delta G, it will be delta H minus Ts. So, or delta G is equals to delta H minus Tds minus S dt for constant temperature or at constant temperature. At constant temperature, this term will go out. So you will be left with delta G is equals to delta H minus Tds. Remember, for a reaction to occur, for a possible reaction, or for a reaction to occur, if some reaction is going on in a chamber, so for a reaction to occur, delta G should always be less than 0. Remember, for a reaction to occur. For a reaction to occur means it's a spontaneous process. If reaction does not occur, if delta G is greater than 0, if your delta H is greater than 0, then it's called endothermic reaction. Endothermic reaction. Endothermic reaction means it will require heat for the reaction to occur. And if delta H is less than 0, it's an exothermic reaction. Means the reaction will release heat spontaneously. So delta H is less than 0 for exothermic reaction. This is some of the concepts for Gibbs free energy. There is one more term called Helmholtz energy. Helmholtz. Helmholtz energy is given by F. Okay, this value of F the value of this F is equals to U minus T into S. So you can keep this thing in mind. Maybe in some competitive exam it may be asked. So if you feel any doubt, please mention us in the comment box. We will provide solution for every possible queries. So for then, thank you friends and have a nice day.